The second question says, the base of an equilateral triangle with side 2A lies along the y-axis such that the midpoint of the base is at the origin. Okay, find vertices of the triangle. Pretty interesting. We have to draw the Cartesian plane first of all. Let's draw the Cartesian plane. These are the x and y axis respectively. This is the origin. Okay. Base of an equilateral triangle with side 2A lies along the y-axis. Lies along the y-axis such that the midpoint of the base is at the origin. So base is this and the midpoint of the base is at the origin. So the total length 2A will be divided A above and A below. So let's mark this will be the base, right? This will be one end point and this will be one end point of the base. Okay. Find the vertices of the triangle. Now, for the vertices, what we'll need is, we'll need another vertex, right? This is the base. So, for an equilateral triangle, what do you have? You need 3 vertices. If you are aware of the base, then you only need this much, right? The coordinates of the base, the endpoints of the base 0, comma A is what you'll have over here, since this distance is A and this distance is also A. This will become 0, comma minus A. These will be the coordinates of A and B. Okay. For forming the triangle, what do you need? For forming the triangle, you need another vertex, and for an equilateral triangle, you can observe that the next vertex will lie, if this is the base, then you can draw this perpendicular bisector and the vertex will lie on that perpendicular bisector, right? So perpendicular and bisector will be this x-axis. You can clearly observe that, right? That's pretty simple. And once you observe that, you can say, okay, the next vertex can be here. Okay. You can have a vertex over here in this manner and this will be an equilateral triangle. But then, can you also have another vertex maybe there and get a totally different equilateral triangle? Yes, you can. With the same base, we can have a vertex here as well and we'll get this equilateral triangle. Oh, is that so? Yes, this is so. So, possibilities of C are 2. This is C1 and C2 are 2 possibilities for the vertex C to give you possible equilateral triangles in this manner. Okay. What are the special things in this? Basically, this particular angle is known to us. This angle is angle of the equilateral triangle. This is 60 degree, right? Or you can say pi by 3. Okay. Once you are aware of this, you can use simple ideas of trigonometry to find the coordinates of this C1 with the help of this length over here, right? This is what you'll be doing. How do we do that? So, for that, simple concepts of trigonometry, yes, and if you observe, if this length over here, if this coordinate is, let's say, since C1 lies on the x-axis, let's call this coordinate as h comma 0, okay. If this is h comma 0, this distance over here will be simply h, okay. This distance over here from O to this vertex A is simply small a, which we are already given. And if you consider this right angle triangle with this angle 60 degree, you can observe that tan of this 60 degree will be this upon this, right? Imagine this, tan of 60 degree will be perpendicular upon this. Okay, so I can write tan 60 degree is equal to h upon a, and that tells me that tan 60 degree is root 3. This becomes h upon a, and which tells me h is equal to a root 3. Okay. This is what you have. So with the help of this, I can say that the coordinates of C1 will be, the coordinates of the vertices of triangle can be A, which is A comma 0, B, which is minus, sorry, just a minute, not A comma 0, it is 0 comma A, right? 0 comma A, 0 comma minus A, these are the coordinates, and the coordinate of vertex C will be A root 3 comma 0. This is what you'll have. Is that okay? Yes. What about coordinates of this C2? This distance will again be h, okay, and the coordinates of this will be minus h comma 0 actually. Yes, that is what you can observe, and a similar calculation will tell us that this or A 0 comma A, B 0 comma minus A, and C minus A root 3 comma 0 will be the coordinates of vertices, this or this. Both the answers are correct for this question, since nothing else is given to differentiate between these two. Right, midpoint of base is at the origin, find the vertices of the triangle. That's the complete solution for this question.